Okay, I think we got cut off on that last term on the last page, so I just want to make sure everybody got that. So we were boxing our constants, the terms without the letters. So we have -3, +7, 7 minus 3, +4. So what I want you to notice is our terms are in descending order, which every answer from here on out should be in descending order when you're working with polynomials. So highest power, degree 9, to lowest power, degree 0. And there's nothing further I can do here because I can't add and subtract unlike terms. So let's go ahead and move to page 5 in our 4.2 notes. So then you look at this and go, oh, ugly. Doesn't matter. We have a calculator. Calculator does everything. But what you need to notice is that this polynomial is not in the correct order. So how we determine order is we look at what letter comes first alphabetically. U comes before V, so this should be arranged in highest power of U to lowest power of U. So that means this is first, and this term should be second, because this is U to the 5th, this is U to the 1st. So we find which letter comes first alphabetically and do it in descending powers of that. So that means -4/5 U to the 5th, B to the 2nd, combined with -2/3 U to the 5th, B to the 2nd, should be our leading term after we find the answer to that. So we're going to type it in just like we see it, just leaving the variables off. So this would be -4 fraction bar 5 plus -2 fraction bar 3. Oops. Yikes. Oh, I forgot to type in my 3. I hit enter. So -4/5 plus -2/3 is -1 7/15. And generally with polynomials, we don't have mixed numbers. So do you remember from the last chapter how to change a mixed number into a fraction? Look at the blue up there. It says mixed number to fraction. So since it's blue, we do second fraction key, and that's -22/15. So that is our leading term. And I'm sure Alex will be the same way, because I saw in their directions when I was taking the test last night, they said, write your answers as simplified fractions. This is a simplified fraction. -1 7/15 is a simplified mixed number. So when Alex asks for fractions, that means they want regular fractions and improper fractions, not mixed numbers. And that's not just Alex, that's everyone that asks for a fraction. That means improper, not a mixed number. Let me take a drink, I'm choking. Sorry about that, I shouldn't eat between videos. So -22/15, and then the variable is U to the 5th, V to the 2nd. Okay, so next, well, we know constants are always last, so we can ignore those. So next we have -4/7 UV squared and -8/9 UV squared. So again, just type it in the calculator just like you see it. So -4 fraction bar 7 plus -8 fraction bar 9, and that gives us another mixed number. So remember, when they say fractions, a mixed number is not a fraction. So then we do second fraction key, negative 92/63. And that was really easy to miss on the test because it said blah, blah, blah. And then the very last line said, leave your answer as an integer or a simplified fraction. So how we had it before, negative 1 and 27/63, that's not a simplified fraction. That's a simplified mixed number. This is a simplified fraction. So I'd write minus 92/63, and then the variable part will be uv squared. Because both the yellow terms, uv squared, uv squared. And then last but not least, we have the constants. So that would be plus 0.2 and plus 5. 5 plus 0.2 is 5.2. Can't do it in your head, just do it on your calculator. So plus 5.2. And now my answer is in descending order, highest power of u, lower power of u, no u. And that's my answer. So pretty much we did the whole problem on the calculator, huh? Subtraction is just like addition with one added piece. When you have the negative outside, you need to distribute that negative. Because remember when we were doing that on our practice test, I told you to write a 1 there, write a 1 there, write a 1 there. It's still the same rule when you have polynomials. And I will tell you, I put this one on the test to be an easy one. And I cannot tell you how many students missed it because they distributed the negative here and then they forgot about all the other terms. Do it first, right at the beginning, so you don't forget. Otherwise, you will forget that negative changes all the signs. So I'm going to show you a nice way to do it when we get to it. But anyway, that's the only difference between addition and subtraction is you do have to distribute the negative with subtraction. So by distributing the negative, we're finding the opposite of some real number. So if we put a negative in front of a, then we read it as the opposite of a or negative a. So if we have a polynomial a and we multiply everything by negative 1, we're going to get the opposite of that polynomial. So to subtract polynomials, we just distribute that negative 1 to the second polynomial. So this is kind of confusing verbiage, so I would just write distribute negative 1 to the second polynomial. Okay. So write the opposite. So what that's saying is, what's the opposite? So we say negative 1 times negative 6 is positive 6a cubed. Negative 1 times positive 5 is negative 5a squared. Negative 1 times positive 5a is negative 5a. Negative 1 times negative 1 is positive 1. So what you should notice is when you do the opposite, really you're just changing all the signs. Negative to positive, positive to negative, positive to negative, negative to positive. That's all opposite means, is change the sign. So if we're asked to do the opposite here, again, we just multiply each term by negative 1. So we get positive 3x to the 4th and negative 11 halves x squared and negative 5x and positive 3. So again, notice that doing the opposite, all it does is go in and change the signs from negative to positive, from positive to negative, positive to negative, negative to positive. That's all opposite is change the sign. Just like when we were doing perpendicular in the last chapter, all we did was change the sign and reciprocate. That's why it was called the opposite. Okay, so let's practice on a couple here. So I see the negative, so I immediately put in my 1 and draw my arrows. That way I won't forget. So what I do is I write the two terms that are already there. 19a to the 5th minus 9a to the 4th. I put them in order if they're not in order. And then I distribute and I line my like terms up underneath. So negative times a negative is positive 7a to the 5th. So I put that underneath its like term. And a negative times a positive is negative 11a to the 4th. And I will tell you, the students that don't do this step that I just did, that try to do it in their head, they're the ones that miss it every time. Because like I said, they distribute the negative to the first term, and they just forget the second term because they get busy going, oh, negative 9 plus 11, that's positive 2. Well, no, it's not positive 2. It's negative 20. So do this step. It takes an extra 10 seconds, but you have so much higher probability of getting the problem correct. So distribute your negative, line up your like terms, and then add. 19 and 7 is 26. We never add exponents in addition. Remember, we only add exponents in multiplication. Negative 9 and negative 11 is negative 20. And again, we keep the exponents the same. So our answer is 26a to the 5th minus 20a to the 4th. And like I said, the terms do have to be lined up in descending order, which they are. Okay, so on 9, they are not lined up, so let's go ahead and put them in the correct order. So 2x to the 5th would be the highest power. And then we'd have negative 5x to the 4th is the next highest power. And then positive 7x cubed. And last, negative 1. So positive 2x to the 5th, negative 5x to the 4th, positive 7x cubed, negative 1. So look at that negative. Distribute. And then as you distribute, line up the term underneath its like term. So negative 1 times negative 5 is positive 5. It's a constant, so it goes under the constant term. Negative 1 times negative 3x to the 4th would be positive 3x to the 4th. So I put it underneath its like term. Negative 1 times positive 4x to the 5th is negative 4x to the 5th. So I go up and put it underneath its like term. So positive 5, positive 3x to the 4th, negative 4x to the 5th, and then my last term will be negative 4x cubed. So put it under its like term. And now we can add our like terms and write what's left. So 2 minus 4, negative 2x to the 5th, negative 5 plus 3, negative 2x to the 4th, 7 minus 4, positive 3x to the 3rd. Remember, when the signs are different, you subtract, keep the sign of the larger. Different, subtract, keep the sign of the larger. Different, subtract, keep the sign of the larger. Different again, subtract, keep the sign of the larger. So there's my answer. Notice it's all lined up perfectly in descending order. X to the 5th, x to the 4th, x to the 3rd, and the constant. So that is what I would recommend. You already heard from me that it's one of the most missed problems, so take the necessary precautions. Put the arrows in. Line up your like terms underneath, making sure you changed all your signs as you did, and then you won't miss it. We'll pick up on number 10 on the next video.